Hello, everyone. Welcome to the Cloud Native Security Processes and Tools presentation. This is Ram Kailasnathan here. I'm the Senior Director of Cloud Native Products. And along with me, we have Johnny, who's leading the cloud engineering team from a security standpoint, and Yasin from our customer from Zoom. As part of today's sessions, you're going to learn about the cloud native security best practices and tools. We're going to go through OCI security tools and products overview. And then finally, you're going to hear from our customer Zoom about their best practices that they are following internally. With that, let's dive in. Let's start with some of the most prevalent cloud native security challenges. Did you know that not all container images on Docker Hub are secure? 20% of the top 1,000 Docker images have at least one critical vulnerability. 20% of the top 1,000 Docker images have no root account password. Containers share the OS kernel. This leads to better utilization. However, lack of proper isolation is a huge security risk. Privileged containers running as root can be exploited by a malicious user. Containers created from images using open source or third-party software could contain known vulnerabilities. Container sprawl is another key challenge, mainly caused by a combination of limited visibility and ephemeral and lightweight nature of containers. Agile took us from months to days to deliver software. DevOps took us from months to minutes to deploy software. And with applications, more and more applications becoming mission critical, security has essentially become somewhat of a bottleneck. And this new trend that we are seeing in DevSecOps, which is essentially the methodology of integrating security tools with the DevOps processes in an automated fashion, this is coming to the rescue of many of the challenges that we're talking about here. And it's not just about tooling, it's also about people and process aspects of things. This ultimately leads to a cultural change, and then the entire organization upskill to think about security. So the mantra is you build it, you run it, you secure it. Shifting gears, let's talk now about some of the best practices that our cloud native engineering team follows. We keep up with the community, and by that, we support the latest released version of Kubernetes. Always, we apply the least privileged security controls for cluster access. We apply very strong network policies to ensure highest levels of security. One good example here is always placing worker nodes on private subnets and isolating sensitive workloads with a combination of RBAC and namespaces capabilities is something that we always follow. Then we always encrypt and safeguard our secrets, which is critical. And through audit logs and other observability tools, we take care of a number of day 2 and day end scenarios. Now, this is a slide that Rajesh talked about as part of his keynote presentation. And one of the things that I want to emphasize here is when you take a look at the cloud native services, pretty much all these services are highly secure and offer the highest levels of infrastructure and data security. Our infrastructure is fully SOC 1 and 2 compliant, and we have several other compliance aspects taken care of, whether be it government or commercial. Our control plane host security is highly protected. Our control plane is highly protected through a combination of host security access controls for patching and monitoring. And resource isolation is something that we follow throughout, using a combination of region, compartment, and at AD and host levels. Now, talking about a little bit about like what does the cloud native services offer in terms of its core security capabilities. We offer granular access control capabilities, IAM policies, authentication authorization controls, secure keys, certificates, API gateway to safeguard your APIs. Also, secure API ingress is another important attribute of API gateway. And then essentially, even offering multi-factor authentication for customers who need that second level of validation. Johnny, in our next section, is going to cover a whole bunch of networking capabilities, all the way from security lists and other network segmentation related capabilities. One of the things that, if you take a look at OKE, which is Oracle's Kubernetes offering, it supports the likes of service mesh, such as Istio, or even additional networking sort of capabilities with the likes of Calico as add-ons. So through this, you gain not only additional visibility, but also additional security aspects as well. I mentioned about worker nodes not being on public IPs as something that we follow as a best practice within. This is something that we also offer as a capability for our customers as well. And then we also touched on a couple of day 2 and day n scenarios through leveraging a combination of monitoring and observability tools. This is something that we actively advertise our customers take advantage of as well. We also offer, OKE also offers API audit logging as part of its capabilities, and that's something that we see a number of our customers take advantage of as well. I want to emphasize that, like as with any cloud deployment, it comes with the shared responsibility model, and this is something that Johnny is going to dive deeper into. With that, I want to request Johnny to come and take over.
Thank you very much, Ram. I appreciate it. And so that's right. As with anything in cloud, there is a responsibility for us as the cloud service provider to build in tools and capabilities. But ultimately, we make a lot of those that are available in the cloud available for you to use in order to develop securely and secure your tenancy. So another way to think about it is that a public cloud provider is essentially going to take responsibility for securing everything up to the operating system. And in the case where you're using the public cloud as infrastructure, you will have a lot of built-in cloud native tools to use in order to enable security for yourself. However, we try to make this as easy as possible. Now, the first thing to focus on is we give you a lot of tools. The whole idea of security best practices, defense in depth. We provide capabilities for preventing distributed denial of service attacks at the edge of your network. Those are automated and they're always running. You don't need to do anything with those. We provide capabilities for monitoring both the traffic that flows in and out of your virtual environment, as well as tools that allow you to control traffic ingress and egress. Those are examples of cloud-native security services that you have to know are there and you have to set them. But again, by virtue of being cloud-native services, they have agile scaling and are very easy to apply and manage. And then finally, there are those sorts of tools that are really about protecting your data. A lot of what we do, obviously, is house and enable the unlocking of intelligence from data, like database cloud service. And so we provide you tooling to ensure that sensitive data is accessed in a limited way only by authorized parties. So again, good defense in depth as you secure from the edge all the way to the core of the virtualized network, which is really the data. All of that tooling is available there for you. And I think the point of this presentation is to give you some familiarity with those types of tools and some guidance on how to best apply them. So user and permissions management. This is really, identity and access management. That is the governance of which individuals and which applications can access resources on the cloud. This is really fundamental. I tend to refer to it as the control plane for the public cloud. Now, the idea here is that you are able to control in a highly granular way both how personnel that manage your tenancies as well as personnel that use resources on your tenancies can access them. Now, in the case of Oracle Cloud Infrastructure, you can see here from this diagram that that all access really goes through one place. So whether you're accessing through the console, you're making API calls, you're accessing from a command line, effectively everything is an API call. As a result, there's a centralized application of policies and policy enforcement. There's also a centralized mechanism to gather activity on the public cloud and put that in an audit record. And that audit record is something that we package up for you, and you're able to send it via a log streaming service to any kind of analytic capability that you might have. This would allow you to analyze it after the fact for anomalous or unwarranted access. Now, what's an example of an identity and access management policy? I'm showing you some here. You'll notice that the authoring of these policies is very intuitive. The idea is to allow you in plain language to define how you want users and or instances, that is applications, to access resources. So that's a really important concept, by the way. So we're writing rules that not only govern how individual users and user groups can access resources and what they can do with them on the public cloud, but we also have the notion of an instance principle, which is essentially how an application, for example, can access backend resources like databases, for instance. So both would come under the construct of access management policies. So part of what is your charter to do is to think through how it is that you want to define access management for your organization or sub-organization, and then turn that into policy language. And then we give you the tools to write that language easily and then enforce it. That's going to limit resource access on the public cloud to appropriate use, and therefore limit the risk from unauthorized use. Now, another set of tools that you are given really for secure network access and connectivity. So what you're seeing here is an example of an Oracle Cloud Infrastructure or OCI tenancy, well, actually several tenancies, and you are seeing that there are constructs in place called security lists, which are effectively governing what can get into and out of that tenancy. That is what kinds of traffic. And effectively, you're controlling and limiting that traffic to, sources that you want. You're controlling whether traffic that is egressing the public cloud is going over the internet or whether it's going over a private path. And security lists allow you to do that. And you're kind of seeing here the reference architecture patterns for how you would apply that. What you're also seeing is the ability to connect securely to your premises. You would do that either over Fast Connect, which is essentially a leased line, or what we call dark fiber, essentially a private connection, or you're doing that through an IPsec VPN, which is over the internet, but again, an encrypted channel of communication, making that a secure communications channel from your tenancy back to your premises. So those layered defenses that we're talking about, you're seeing them in action here to essentially control traffic paths, to provide secure communication. And then on the outer perimeters, you're seeing the shared services like distributed denial of service protections, web application firewalling, and identity and access management, which is essentially a common service to the tenancies that you're levering to write those policies that I just showed you. That is really your most granular control mechanism for limiting resource access. Now, another application of the network security controls is called microsegmentation. In addition to security lists, what you're seeing here is an OCI construct called network security groups. This is really important for developers because not all of your workload types have the same security profiles. So you take a common application, for example, it has a web front end, an application tier, a logic tier, a set of backend databases. You might be using that for development purposes, that construct, or it might be a production application. Either way, those workload types, the web front end, the application tier, they have different security profiles. So we want to group similar resources of a similar security profile together and then limit access to those. So a perfect example of microsegmentation is I might allow internet connectivity to my web front ends, but I would not allow any kind of connectivity from the internet to my database tier. There's simply no need for that. Only my application tier is accessing the database tier. And your network security groups ensure that there's simply no traffic path, no way in to that database tier from the internet, essentially. Microsegmentation is really a best practice for developers especially. And again, these cloud native tools are there and available to you to lever, as is a lot of help online for how to apply them. Now, one of the fundamentals for data protection as we go into our further layers of security is encryption or cryptography. This is the idea of taking clear text and obfuscating it, or making it unreadable to the human eye and inaccessible to anybody that would try to access it. It's very important that valuable data that we might have in block object storage in our databases be encrypted. And so we do that for you by default. So all data at rest, at least in Oracle Cloud Infrastructure or OCI, is encrypted at rest with very strong encryption, AES keys, and as is database data. In fact, actually, data in transit is also encrypted to ensure that some intervening party that is trying to eavesdrop isn't able to intercept the data and steal. So these concepts of encryption are extremely important, as is the way that you enact encryption. So as I mentioned, we encrypt data at rest, for instance, by default. We do that for you, and we can do it using cryptographic keys that we generate via our service. But what is probably more interesting is to have you import your own keys into our public cloud, so that effectively you're using keys that you have introduced and are managing for the symmetric cryptography. So the way that this is done is via something called we call key management service. Key management service is an OCI native service that is essentially allowing you to manage your cryptographic, your symmetric cryptographic keys at scale, rotate them, revoke them, and this way you're not having to sort of keep track of everywhere that they are. The service takes care of that for you. What the service also does is it takes those symmetric crypto keys, and if you wish, it stores them in a FIPS level 3 certified hardware security module that is tamper-proof and essentially an additional layer of security that just makes it very difficult for those keys to be stolen and fall into the wrong hands. Key management service is doing all of that for you. Again, giving you these options of either using cryptographic keys that are generated by us, the public cloud provider, or ones that you have imported into the service. Another really interesting item here, though, for developers is the secrets management service that accompanies the key management service. Together, by the way, this whole construct is called OCI Vault. Now, you have other secrets like passwords and tokens, and those can be very hard to, as certificates, and those can be very hard to keep track of. And we don't want you doing things like essentially exposing them in your code. or failing to rotate them, which increases risk, because frequent rotation is essentially going to ensure that if they're compromised for any reason, an attacker doesn't have very much time to do things with them. So we want frequent key rotation. We want to make it easy for you to essentially access them without breaking your code. So the secrets management service is giving you the mechanism to do that, again, in a cloud native fashion. So two pieces of the same construct here: OCI Vault key management service for your symmetric cryptographic keys, as well as your database encryption keys, and then the secrets vault for storing your other types of secrets, tokens, passwords, certificates. Now, finally, we come to a very, very important construct here, cloud security posture management. The whole idea is, well, you've availed yourself of all these great security services, you've set up your network access or virtual network access and secure connectivity correctly, you've set up your access management policies, but things can drift and happen over time. You need to keep vigil over your security posture and ensure that you're always dialing down risk. And that construct is called cloud security posture management. We at Oracle have some very interesting ways of doing that. All public cloud providers provide some measure of it. We really aim to make it as easy as possible for you to use in our development community without requiring you to be deep security experts. This can really put a heavy burden to making use of cloud native security. And so we have two constructs here for cloud security posture management. Think of it as kind of a belt and suspender strategy. We want you to deploy securely, so we give you this concept of security zones, and we'll take a look at that in a moment. And we want you to be able to continually operate securely, keep track of what has changed, like state changes in your configurations, and be able to dial down risk. And that's the Cloudguard product. So together, security zones and Cloudguard are effectively combined into mechanisms by which we ensure that best practices for security are continually enforced, be that in a default way or by giving you the awareness and the visibility so that you can continually enforce and optimize. So one of the things that it can prevent is something that all of us know is too common. You take the concept of a private bucket or an object store that all of a sudden has been made public because an attacker was able to steal the authentication credentials maybe of someone who accesses the cloud, goes in and flips the bucket open. Consequently, now the attacker has a pathway to go in and steal sensitive information, possibly sell it. We've seen way too many headlines of this. We know this is a very common occurrence. We want to prevent it, and Cloudguard does that very thing. It's essentially going to keep track of the configuration, the initial configuration, as well as a state change, and has the ability to either alert you that a configuration change like this has happened, meaning the private bucket went public, and flags it as a high-risk security event, which you can then go do something about. But really more interestingly, Cloudguard is able to even remediate the risk in an automated way if you've set it that way, meaning it flips the bucket back to private automatically and then reports out to you that that action was taken. So that's a lot to take in. Why don't we take a look at it live and see how it works. Here I am logged into Oracle Cloud. I'm going to scroll down to security and select security zones. You can see here a number of security zones are pre-populated, and I'm going to go ahead and create a security zone. Let's name it Johnny Maximum Security Zone. This is a newer security zone, maximum security zone, and I'm going to select the compartment and resources to which this applies. Now you can see Johnny, maximum security zone has been created, and we're applying a maximum security zone recipe. This is essentially a set of default best practices that ensure a sound security posture, and they are applied by default and cannot be changed. There are about 30 out-of-box policies that are included here, and they cover core services like block, object storage, file storage, and they ensure things like encryption being applied, as well as restricting data movement out of the compartment. That ensures that sensitive data won't leave the compartment due to unauthorized use. Now let's have a look at the compartment to which the security zone is applied. I'm going to transition to the compartments view, and we'll have a look at the compartment in which I've created the new security zone. And you can see here, it is enabled and has been applied. Now, what happens when I try to violate one of these policies in the security zone? I'm going to go ahead and try to create an object store. And I'll put that object store in a security zone, the security zone that I just created, Johnny MSZ. So I'll select my compartment and try to create a bucket, a new object store, essentially using Oracle managed encryption keys. So let's create that bucket. Now, encrypting using Oracle managed keys is not advised. In the case of a maximum security zone, we want to encrypt using your managed keys, keys that you have imported. And so that's flagged as a security zone violation. It's essentially not letting me do the thing that is a riskier behavior. This is where Security Advisor comes in. Now, Security Advisor is essentially a tool that we've built to make it easier for you to apply security best practices. In this case, Security Advisor is guiding me through step-by-step a workflow for creating an object store using customer managed keys. So we'll call this new vault. And as a next step, I'm going to create a bucket key. I've selected here a strong algorithm, AES 256 bits. And once I click next, I have effectively completed the workflow for creating a secure, highly secure object store using customer managed keys. Now, when it comes to cloud security posture management, we want to take a look at Cloudguard, the tool that I was referencing earlier. Cloudguard is essentially going to monitor configuration and user activity over the entirety of your Oracle Cloud Infrastructure estate. Cloudguard is essentially a command center for ensuring that you're dialing down risk and maintaining a high security posture. And it does this in a single pane of glass. So it gives you a security score. In this case, the rating is excellent. So the higher the better, and a risk score, the lower the better. The risk effectively represents our opportunities here, or recommendations to reduce risk by doing very actionable things. The problems that we have surfaced that constitute risk have really been grouped or compartmentalized here by severity, so that you can focus in on the most critical. You can view these problems by compartment or by region, selecting which part of the world you want to zone in on to address critical or high risk issues. We also overlay those problems onto a map so that you can see whether one region in which you're operating has more issues than another. Finally, as I scroll down here, we're presented with some trend lines of both the security score as well as the problems. This not only allows us to see that we're able to maintain a security posture over time that is ideal, it gives us a way to report on that security posture, to management or other security stakeholders, and ensure that essentially things are trending to a desired or compliant state. Now, the way that problems are surfaced are through detectors. We have a number of detector recipes that are provided to you out of box. These detectors are two types. We have configuration detectors and activity detectors. Configuration detectors are looking for essentially settings, and those settings can constitute critical or low-level security issues. An example of a critical security issue is where the bucket is public. So this is one detector that we've set and we've enabled, and we're ensuring that making a bucket public is not allowed. So there are various detectors here out of box, and you effectively can see that they're being enforced in this particular OSID or Oracle Cloud ID. When we look at detector recipes, we also have activity detector recipes, and these are effectively looking at what traffic types are or what users are doing within our tenancy. One example of a user detection is a suspicious IP activity. This is the case where, and I'll expand this so we can see, a user has logged in from a known malicious IP, and this constitutes a risk. So one action that we can take via our responders is to disable this user so that they're not able to change any settings that would effectively allow them to steal data or do anything that's unauthorized in the tenancy. This combination of problems, detectors, problems, and responders constitute a workflow by which we are able to maintain a cloud security posture that is desired and close to ideal, and we're able to do this over time. With that, that concludes our demo. I'd like to welcome Yasin from Zoom. Thank you very much for joining us today, Yasin.
Thank you, Johnny and Ram. As Johnny mentioned, I work for Zoom, where I manage a cloud ops team in addition to system administrations. We've been happy customers of OCI for some time now. As you all know, Zoom has experienced very rapid growth post-COVID. We are a video collaboration company, and once the pandemic hit, we started, the customers started hitting. They started using Zoom as their preferred collaboration tool. So we saw our user participation, daily user participants go up from 10 million daily participants to about 300 million daily participants in a matter of weeks. So we've seen this rise, and traditionally Zoom has been like a hybrid model, wherein our web services and data layer sat in cloud, and our real-time services were in our co-locations in our own data centers. So we used to run a hybrid infrastructure, and there were a couple of reasons for this. Number one was obviously it's expensive to run media services out in cloud mainly due to DTO. Plus, we also wanted to make sure we control the user experience, make sure that our meetings are frictionless, the video and everything. So that was the reason. But obviously, because we experienced this growth in such a short amount of time, that we quickly used up all our co-location data center capacity, and we had to turn to cloud. That's where we started using. We reached out to OCI and moved some of our media services out to OCI. So if you see the slide here, the earlier model was just web services and data layer in the cloud, meeting services in our colo. The current model, we still run a lot of our meeting services in colos, but a good number of our meeting services now are in cloud. We have thousands of meeting services in OCI region across the globe. And so far we've been very happy with the quality and the security of our media services. Ram, can you switch? So just to talk a little bit about our growth, we, as I mentioned, we had to quickly scale up all our services, which included our web, our client, our document management, our NoSQL databases, web gateways. Obviously, we experienced very massive growth, but the growth that mostly went on to OCI was our media services that stream our meeting audio and video. So those were the services that have been put on to OCI infrastructure. So as I mentioned, we've been very happy so far with all the services that OCI has provided. We very frequently use OCI Management Console as a single, single pane of glass for all of our monitoring. We've requested, since our customers require us to announce the IP addresses that the meeting services run on, we've requested contiguous blocks of IPs, and OCI provided us with the FIS blocks that helped us, make the meetings secure for our customers. Right now, as far as the security is concerned, obviously we are very happy with some of the things that Johnny mentioned, which is, default encryption of our data in transit as well as data at rest. And then in addition to that, we also use, VPC flow logs to monitor any anomalous traffic. We obviously ingest the VPC flow logs in our SIEM tool using functions, and we've set up, monitoring and alerts for these SIEM tools. In addition to that, we use NSGs, OCI's NSGs, which are network security groups, to filter out the traffic for our obviously our applications, to make sure that all the traffic is secure. We also restrict traffic to things like SSH and all only to our VPN in our offices. So those are some of the main use cases of the security that we use from OCI.
Thanks a lot, Yasin, for the fantastic best practice guidance that you guys are following within Zoom, and that was very useful. Thanks a lot, Johnny, for the demo and the detailed security tools overview. Again, that was very well done. Just to wrap this up, I want to sort of say that we initially started by talking about some of the challenges and the best practices that we follow within the cloud native security engineering team, and some of the security capabilities of the cloud native products, particularly the Oracle Kubernetes engine. And then we also went through the security tools overview, and then finally sort of learned about some of the best practices that Zoom is following, tackling some of the massive growth, yet protecting and keeping their security first mindset. Thanks.